Now before I go any further, I have to take you back to Year 8 algebra and talk to you about the equation of a straight line. Now predictions are often based on the assumption that the relationship between two variables are linear. That is, a straight line tells the story. So let's use a quick example. Suppose you have $100 in your pocket to spend on chocolate. On the x-axis, you have the amount spent on chocolate, ranging from 0 to 100, and on the y-axis, the amount left in your pocket, ranging from 0 to 100. Now if you spend $10, you can see that you have $90 left in your pocket. If you spend $40, you have $60 left in your pocket. And if you keep doing this repeatedly, over and over, starting with $100 and spending different amounts repeatedly, you'll find that you have a straight line that connects the $100 on the axes that tells the whole story. So can you write this equation? You may recall from your education about algebra that the equation of a straight line is y is equal to a plus bx, where y and x are the variables being represented on the y and x axes. B is the slope of the line. A is the intercept or the intersection of the line with the y-axis. In other words, it's known as a constant. So this is a line with a negative slope that's inclined at 45 degrees, which I know means that B is going to be negative in this example. So y equals a plus bx. So when you don't spend any money on chocolates, in other words, it crosses the intersection, we have $100 in the pocket, so the constant a is 100. For each dollar we spend, we lose $1 in the pocket. So the b value is -1. So the equation of a straight line is y equals 100 minus 1x. With that equation, I can estimate that if I spend $30 on x, on chocolates, then y, the amount left in my pocket, is $70. So the equation of a straight line is your y hat is equal to a plus bx, where y hat is the outcome variable and x is your predictor. B is known as the B weight, or the regression coefficient. B is a parameter for the predictor. It represents the gradient or the slope of the line. This is like the strength of the relationship. The more the slope, the stronger the relationship. It also represents the direction of the relationship. If B is negative, like in the previous example, then it's a negative relationship. If B is positive, then it's a positive relationship. A is known as the constant or intercept. A is the value of the outcome variable when the predictor is 0, i.e. when it intercepts with the y-axis. Okay, enough of algebra. I wanted to put this out there because a linear regression is about using the data that we've already got to create a line of best fit, which is that equation of a straight line. So for example, you may have an idea that attractiveness is related to the number of dates you get. So you would create the equation y equals a plus bx. So in other words, number of dates is equal to a plus b times attractiveness, where y is the number of dates, where a is a constant, and x is some measure that you have of attractiveness. So we could predict now the number of dates from how attractive you are. A tells us how many dates a sample would have if attractiveness was rated at 0. In other words, not attractive. B tells us the relationship between two variables. So if B is positive, it's positively related to the number of dates. If B was negative, then attractiveness would be negatively related to the number of dates. And if it was 0, then there's no relationship between the number of dates and attractiveness. So let's look at the model when we have a different B. So we could look at 3 models that have the same intercepts when the predictor is 0, but they have different shapes. For example, the number of dates is a function of attractiveness. If attractiveness has no relationship with the number of dates, then you would expect a flat line. In this case, B is equal to 0. What about if there was a relationship between attractiveness and the number of dates, and you found out that the more attractive somebody is, the more dates you have? Then you would find a positive relationship. In this case, B is greater than 0. What about if there was a relationship between attractiveness and the number of dates, and you found that the more attractive somebody is, the less dates they have? Then you would find a negative relationship. In this case, B would be less than 0. So the B's define the direction of the relationship and how strong it is. The steeper the line, the stronger the relationship. So let's look at a model when we have a different constant, A. So the typical scenario is attractiveness is positively related to the number of dates. So now we have many different intercepts. So the samples that we are looking at may have different levels of the number of dates when the intercept or attractiveness is 0. So let's step away from attractiveness and number of dates one has, and let's use a music example and see how these regression coefficients are used to make predictions. Now, I often hear music playing on the radio and I think to myself that I'd like to download that music from Spotify so that I can listen to it in my own time. So let's imagine that we're interested in predicting the amount of music downloads on Spotify, so that's the outcome variable, from the amount of airtime that the song got on the radio. So if we go back to the equation of a straight line, where y is equal to a plus some b coefficient times x. Now I'm interested in predicting music downloads, that's the outcome variable, from the amount of airtime on the radio, that's a predictor. We could summarise this relationship using a linear model by replacing the names of our variables so that music downloads equals A plus some B coefficient times airtime on radio. Once we've estimated the values of A and B, we would be able to make a prediction about the music downloads by replacing airtime on radio with a number representing how much time on airtime was recorded. For example, suppose that A was 20 and B was 8. Our model would be music downloads is equal to 20 plus 8 times airtime hours on radio. Note that I've replaced the intercept and the regression coefficient with numeric values. Now we can make a prediction. If a particular song received 5 hours of airtime on the radio, we can replace the airtime hours on the radio with this value and solve the equation of how many music downloads of this song there will be. So in other words, music downloads is equal to 20 plus 8 times 5, which is equal to 60 music downloads. So based on this model, if a song gets 5 hours of airtime on the radio, it will get 60 music downloads from Spotify. Please note that this is a prediction, and with any prediction, there's an error. This value of 60 music downloads is known as the predicted value. Let's have another example. Let's look at another example, but this time I'll use SPSS and go through the output in much more detail.